The Joy of Functional Game Dev, Project 1, Episode 10. Hey again, everybody. Nice to see you. We're starting at the tag of v0.9, so the end of Episode 9, start of Episode 10 in the GitHub repo. And to remind, we are working on center of mass and smooth movement today. And that probably won't take too long, so maybe we'll get to stubbing some of these screens in. But this is definitely the focus. And if we get to nothing else, let's get to that. And I left it all a mess. My goodness. Okay, so step one, we're going to do the. We're going to render the texture by. So new rectangle, map. Since really we only care about the width over 2, texture height over 2. This is cheesy, and we're going to want to do this a better way later on. We're going to want to say, well, no, I wanted to be able to define the middle of the texture as being 0.25 of the way or whatever. But in our case, the center of the texture is the center of the texture, so texture width over 2, texture height over 2 will give us that which we hope for. F2, bulk. Oh my goodness! Oh, that's fun. That's interesting. It also works with our background texture. Okay. So what shall we do about that? All right. I think in the case of, so when we're putting the play field, we're going to put board columns times pixels per cell over 2. Is that going to work? Oh, well, 2.0, my bad. 2.0. And I would do board rows times pixels per cell divided by 2.0. Just match the type. Draw texture. Oh, it's an X int, Y int. 2.0. We wind up with, we have cell, we have pixels per cell. 2.0, so we're going to divide by 2.0 px. We're still at a float. And send it to an int. And that should shut it up. Basically, don't care, want it rendering in the right spot. So okay, now that's in the right spot. See, that's a little close, but at the moment can't do anything about it. Alright. And also one of the weird things is I can't see, here's our goofy rendering now. So my upper corner is I can't go past here, and then I can't go past there, which is as far as I can go for if I were still using the upper left. So that doesn't make sense. So I need a bounding box that is allowed for these things, and that's so I can randomly generate within them. So I need so I'll need to change that, but that's not terribly important just yet. Let's take a look at what we want to do for smooth movement, because, well, center of mass was really simple. This next one should be really simple too. Not quite the same because, where are we at? So here's the movement table. So for these keys, we have all that, and so anymore, I don't want, let's go delta for key. So, okay, when I let's take a look. Alright, here's the board state. So, update play state, there's a new board state. Update play state, so I'm going to grab the key state and we're going to, okay, updating the keyboard state. Clear events, move avatar. Alright, we're going to go to move avatar. We're going to change how things work. So the keyboard state, determine delta. So here in determine delta is where, look up delta for key. So actually, alright, we're going to say movement table contains key and the keyword state, the key is down. Yes, this is exactly what we want to do. So if the key is down, and the movement table has the key, then we're going to return that up in our lookup, and when we're going to reduce, we're going to add the location to combine them together. This way, I no longer have the problem of you have to be pressing the key to do it. I'll just show, because now, and now, if I hold it down, yep, and that's way too fast. So now I'm moving that per I'm moving that. I'm moving at this rate. And what I want is I don't want it in pixels, because I don't care about this. And then also I need to normalize. So I now have, oh, okay. So now it gives me a float px. I want to normalize my delta. And what I mean by normalize, mathematically normalize. All you 3D developer guys, so x delta y equals, and I don't know where this stuff is, so let, and these are going to be float px. See, I'm wondering at this point, can I inboard state? Because there's the one that where I do the distance. That's in my update. The distance. Oh, maybe not. Nope, it is here, isn't it? So there's distance. We're going to make this unit independent. We do that with the almighty underscore. So we need you over here where I normalize my delta. And we're similarly going to do this. So let this is going to be interesting. Because in order to, well, I don't really need the distance formula. That I really don't. It's so let that's magnitude equal delta x times delta x plus delta y times delta y. We send that to squirt. Squirt. So there's our magnitude, and we're going to return no, we will actually call it U. We want to make sure they're the same, because I do. I want to make sure it's homogeneous. Homogeneous, whatever. So normalize, I want to do that, and I want to divide by 1.000 of a U. I want to be dimensionless. What don't you like? Non-constant, non-zero constant cannot have generic units. Not have generic units. Yeah. Huh. Can I bring this to a float? Can I do it to regular float? It's a float. I can do it. Oh, alright. Because really what I do, I want to go delta x divided by magnitude. Delta y divided by magnitude. I'm still new to units of measure. So then I normalize. So I'm going to have my, so it's going to be between, it's going to be a 1.0 time in a particular direction. So my magnitude will still be 1. It'll be the unit. So what I want to do here, cells per seconds. So okay, I've got pixels per cell. That's pixels per cell times 1 cell. So I wind up with like divided by 0.0 seconds. Okay, well, 0.0 px per seconds. And I think I don't like the fact that it's seconds. I don't like the name. You know what, this should work. And so cell per second. So this should work. So then, movement table, pixels per seconds. And we're going to go to the definition, and we're going to change it to second. And what we're going to do is we're going to fix all the places where it's broke, because I should have had it not be, seconds is not defined. That's, what happened here? Get rid of you. And look up, it's pixels per second. Pixels per second. Still going to be broken, of course. Little angry red underlines. Okay, boom, boom, boom. Type seconds. So get times pixel per second. That's way better. Cells per second, per second, per second, per second. And now, so the delta is in pixels per second. And change, it's going to be delta position. How about we call it what it is? It is called velocity. Why don't we work in actual stupid units? Velocity is in pixels per second, and I need a number of seconds. So, where is move avatar used? There is a delta, which is a float second. We're currently not doing so. So it's velocity times the delta, and then we send that together into there, pixels per second. Float in seconds, da-da-da. Float times float. Well, and that's very bizarre, because delta is, let's clean you. Build. Oh. Okay, what don't you like? What's delta? Delta? I got velocity. Okay, so here's velocity. I see now. Okay, so let velocity x, velocity y. I understand now. Velocity x times delta, velocity y times delta. Kelta, the deltas that lived in Gaul during the time of Rome. Let's try it. Gonna be happy with me now? Okay, and given a this times float second should be float pixels. Yoy. So it's not liking me. What else we got? We got second. These. Ooh, avatar keyboard state. There's a delta in here. Delta. Type seconds. There's that. We have that last little one. Okay, still a fail. What don't you like? I'll say let velocity equal that. Fix that. So velocity is a float px, float px. So then location, board state player, given a, it's very, very strange. Board state player. I got a board state player. So its player is a float px and that. Flare, which is affecting that. Velocity, which is that. It's very, very odd and strange. So, it's a thing that takes a... It's given a... What is add location? What is your deal? It's very, very strange. So let's do this, because there's unnecessary steps here. So it is a... Oh, it's determining that, and it's actually a float whatever. So it is confused. The compiler is confused. It doesn't really matter what kind of whatever it is, add location can do it. So now, it got confused. It's thinking. Okay, so now, okay. Oh, thanks, F# compiler. So, F2, where am I? What in the world happened? Okay, well that didn't work. So, if the keyboard state is key down that, then the movement table up key. Well, this looks like a job for look up a delta for key to see what's going on here. So, which key are you? You're left, and so what? So 0. So where's my... F9. Eek. So reduce add location. So where's my... Growth. Look up delta for key. Old keyboard state. Keyboard state. Left, up. I think this is one of those things where I may need to print fun it. So if the movement table contains a key and so what I wanted it to do is look up delta for key. So all those, what key are we dealing with? Keyboard state. My goodness, so what is so all my movement keys, which is a sequence of keys. So mi, so okay, let temp equal that. Alright. Sometimes, kids, you just gotta do things, and then temp gets sent through there. I want to see what's going on right here. So F2. Temp, which is the result of a bunch of zeros. So let's put it there and determine what is velocity. Not a number, not a number. Aha, that would be the problem. So how did I get there? Reduce add location. So temp. The normal. Yeah. So I understand the problem now. So if magnitude is not 0.0, then else 0. Well, you can actually delta x, delta y. We're cool there. Can't we do it? Does it work? The velocity is 0, 0. So now I'm not at the velocity of not a number, not a number. Oh, kill. Killer. Wow. So what is pixels per cell? So there's something not right here. So let's look at. It's very strange. Per cell times 100. That's. Hi. This is. Hi. I like to flail around just to do stuff like that. 2. Still no crawling. What is up with that? Oh, nope. 1 comma. No. So we should have the movement table pixels per second. So that's the number of seconds. Do we not? Velocity equals. So our delta here. How big is our delta? Curious. So what's our delta? Not very much. So that's the number of frames. And let's go up to call stack, shall we? Update the games. Here's the game. No, not that one. So what's the delta? The delta total seconds is that. 1.0 second. So the number of pixels that it moves, that is total seconds, it's 1/60th of a second. So 1/60th of a second times the so this isn't working out at all. What is going on? So that's how many seconds happened. What's our velocity x and velocity y? Well, that's going to be 0, so oh, is our normalization not working? You know what? I have a suspicion that I mistook something with normalization. That kind of. Okay. For now, we're going to not normalize. we're going to see what happens. Such a hunch. This is a hunch, not exactly great computer science here. Okay, so, keep going. Where's that? And so, yep. That's much, much better. Still pretty awful. I don't know. Let's go. It can go 10 cells per second. And now it should work, which means that my normalization function is whack. Ding. Okay. That's much more like it. Okay. Now, time to find what is wrong with normalization. So, what did we do that's wrong? Normalize. Okay, normalization. So I take the deltas, I take the square root, and that should really work. Because that's really what I want. But why, when I'm normalizing, do I slow it down? There's something weird happening here. Have to. He's just crawling. So how am I? Delta X. Putting this here so that I can only 0.0 of some U's. So cast to a float then. Okay, so only here. So I want to know delta x times delta x floats 1 times 1 plus 0. The square root of that is 1, and it's a float. Then why wouldn't I want delta x divided by that? It just doesn't make any sense. Oh my goodness. Cause normal. Nah. So the vector that's coming in here, so it will cap it out at 1 per. Alright, so my normalization is Bobkus. Alright. So, at least for now, normalization is off the table. Because I'm dealing in pixels per second and not. And normalizing that, it's gonna do it to a crawl. Alright. There's that. Bing. Whoa. Bing. Blink. What's going on there? Boom, 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 boom. Oh, that's interesting. Boom, boom, boom. Pow, pow, pow. So this is getting much betterly. Of course, the reason I was doing normalization is that this was because this goes faster than this, up and out of time, F2. So we go up and down, but this goes, well, doing the same. So square root of 2 times that, and that's what I was attempting to avoid. It's okay for now, and I'll have to normalize it a different way. So perhaps my normalization is a maximum speed, or a factor that goes in there, and that could well be what I have to do. Ooh, hey, that was cool. Blink. Blink. I think this is much, much better. We don't have the ridiculous amount of perhaps we say 5. See, and then maybe really it's the change the units here. It's into just per second units, and then we multiply by something later. Could be. Of course, this is now me having the speed. Go. F2. So now here he is at half speed. And what I'm trying to do here is trying to look at what sort of speeds I'm going to want for this right here, which is 5 times. The speed is definitely 5 cells per second, which, if we're right, because there's, I forget how many cells. So 5 cells per second. This is about as sluggish as I want it to be. Because let's take it down 2.5. And 2.5. So go. Maybe this isn't so bad. This is the when you're really tired and really depressed speed, and you'll want to improve matters so that you don't have this kind of penalty. So now one of the things we're going to do is we're going to manipulate how much the speed is based on other conditions. We're going to start adding other things that you can gather. We're going to add the heart, and I'm still not sure whether to leave it at sleep or to make it food. I'm not sure yet. We also need to work on reclamping these things, because this makes no sense. And it looks like, so alright, we've now got, where's my Trello? Trello. So center of mass, we totally killed it there. The label, take out that. Did that. Smooth movement. We're not completely done yet, but we got it in there. And I think we're going to be done for the day. This is good. We're getting lots of stuff done. We have some other things, so now we're getting into hey, let's do something cool. And we're gonna wind up changing some time. I think we're going to wind up changing how much time there is in the game, because rather than 60 seconds, which isn't a very long time, you want it to be a little bit, or we want it to be a multiple of that. So it's going to be a multiple minute game. Not sure yet how long we want it to be, but we will definitely investigate that. I think a good 5 minutes is a good minimum, maybe 10. Maybe it's one of those things where we select it. But in any case, we've got a lot of cool stuff done, and a lot of cool stuff left to do. A lot of here have a help screen kind of stuff where we can stub them in, but it'll just say help screen or option screen because we don't really have a whole lot of options yet to do. But we'll get there. And that's what we got for today. We'll see you next time. The Joy of Functional Game Dev, Project 1, Episode 10.